All right. I think we are live. Welcome, everybody. Hello, Dariusz. How are you?
Hello, thanks for having me. I'm excited to present this exciting material that I have.
Awesome. Well, we're very excited to have you. So welcome everybody to the Golden Path to Spring One. As you know, we have a series of talks leading up to Spring One Explore happening in August in Vegas. I'll give you a link to that information at the end. But I'm really pleased. My name is Cora Iberclad. I'm a developer advocate here at VMware. And I'm really pleased to welcome Dariusz. I was practicing his last name, so I'll try to say it, Dariusz. Jędrzejczyk. How'd I do?
It's more or less good. Yeah, thank you.
Okay, 7 or 8 out of 10. Okay. And you're joining us. Where are you joining us from, Dariusz?
I'm joining from Krakow, Poland.
Awesome. And I guess it must be late there.
Yeah, it's the evening. Still not dark, but it's getting.
Nice. I like those long summer days. That's my favorite part of summer.
Yeah, they're getting longer.
Cool. So I see that for today, you have a presentation for us on reactive and imperative context propagation in Spring applications. So I guess, do you spend your days as a Spring developer, or what's your day job?
So I work on the Reactor team, which is part of the Spring team at VMware. And most of my days are spent on Reactor core, and sometimes interacting with other teams such as the Micrometer team and also the other Spring portfolio teams. So quite exciting.
Amazing. And how is it in your career that you came to join the Spring team?
Oh, I was a big user of Spring products for years. So I'm quite happy that I made it to become the creator of those amazing products. And I joined last year.
Oh, wow. Okay. Do you find I'm not really a coder, and much less can I imagine I feel like working on the Spring team, you have to have sort of maybe a shift in the way that you think as a creator of the project that will sort of enable people to use it easily. You have to think about it from a different perspective. Did you find that was a bit of a mind shift, or not really?
Definitely, it is a mind shift, because when you're on, let's say, a product company and you're using a product, you're just, a set of libraries. You're thinking how to solve my particular problem. With creating a product that's used for various scenarios, you have to consider quite many of them, and sometimes compromise, and on other occasions you need to limit the scope, not to hurt anyone who's using the product. So it needs to be designed carefully and having everyone in mind.
Cool. Awesome. Well, I don't want to eat up more of your time. So are you ready to go? Can I add your deck to the stream?
Yes, definitely. I'm going to be sharing my screen.
Okay, perfect. Okay, so what's going to happen now is I'll add your shared screen so that everybody can see it, and then eventually I'll take myself off. And as soon as can you see the screen? I can give you a countdown if not. But as soon as I disappear from the screen, basically, you can start your presentation. And then what we just want to tell everybody who's joining us, participate in chat. You have already some comments in Polish that I'm not going to try to read, but people saying hello. And feel free to ask questions in the chat as we're going through. If there's a question that's very relevant to what Dariusz is saying in the moment, and Dariusz, if you're focused on your slides, I'll jump in and ask you the question. If there's other general questions, we might hold them till the end. But definitely, let us know. If you don't have a question, just say hello and tell us where you are. So that being said, I'm going to hand over. So here's your slides, Dariusz, and then I'm going to...
visible. Great.
Awesome. Okay, so I'm going to step off here, and the hour or the whatever time you need, the half hour, 45 minutes, however long you want to go. The time is yours, Dariusz.
Perfect. Thank you. All right. So today we're going to discuss context propagation in imperative and reactive scenarios. And we have some exciting news for the latest Spring edition, Spring Boot 3 and Spring Framework 6, and the Reactor 3.5 edition, which contains some exciting features that you can use to combine those different paradigms. But they all serve the purpose of making your application observable. And what that means is, in most situations, having logs, metrics, and traces, which, according to Cindy, the author of Distributed Systems Observability, are the three pillars of observability. We will focus on logs, but then we will try to transition to more things such as tracing and metrics with the Micrometer product. The thing we're going to do today is actually build an application. So this is mostly going to be a demo. And we are going to start with an MVC application that logs and uses the SLF4J's MDC to have also a web client which provides us with reactive chains, in which we will like to see logs that have correlation identifiers. And we will migrate the application to WebFlux and back to MVC while maintaining log correlation. And in the end, we will add Micrometer to allow us to provide observation, which is the latest feature of Micrometer that allows to extract more than just logs out of a single observation. We will have metrics and traces. But before we start with the demo, we still have some background knowledge to cover. And this is going to be a short intro for a few theoretical concepts. One thing we'd like to discuss is the Context Propagation library, which was born out of the experiences of Micrometer and Reactor teams, and also the other Springfield portfolio products, which had the necessity to transport contextual information between different execution models. So this library allows us to take some kind of object, be it a GraphQL context or Reactor context or Netty attributes, or actually any map-like structure, and transform that kind of object to ThreadLocal values, and also be able to transport those ThreadLocal values back to such a context object for the use of the actual library that is going to provide some features for us. As most third-party libraries that provide logging, tracing capabilities, they often rely on ThreadLocal state, which serves the purpose of having an implicit way of providing information without the application logic to need to transport them. So in order to use the Context Propagation library, we need to import it. In case of Gradle, it would be this dependency. And the next thing we'd like to cover is the Reactor context, which in the latest versions of Project Reactor in 3.5, we are interacting with the Context Propagation library when it is in the current class path to provide a seamless experience that you don't have to interact directly with the Context Propagation library to achieve the purpose of transporting ThreadLocals back and forth between the Reactor context. So let's discuss what Reactor context helps us to achieve. Imagine a situation where there is a reactive pipeline, such as this one, where we have a publisher upon which we declare some operators. In this case, this is an operator A, which is upstream from an operator B. And we would like to subscribe to that reactive chain. But we also have the context write operator, which allows us to alter the context that is going to be available upstream from that operator and applied on top of whatever kind of context has been made available by the subscriber. So in this case, the green color would be visible to all the operators upstream from the context write, and downstream from the context write that we see in the center of the screen would be whatever context comes from the subscriber. So as we can see, the rectangle on the top, which is green, is a combination of whatever values have arrived from the subscriber with the values that have been written on top of that context. And with the combination with the context propagation library, we are able to utilize the reactor context to provide the source of truth for propagating that information to thread locals. And reactor core allows us to interoperate between the context propagation library and the reactor context using new operators that have been added, such as the context capture, which is available both in mono and in flux, to capture the current thread locals into the reactor context. And on the other hand, we can use operators such as handle and tap to restore those thread locals for the execution of the provided lambdas to those operators. In case of handle, we will be acting upon a next emitted value, and we have access to the sync, which contains the information about the context, but Reactor automatically makes those thread locals available inside the body of that lambda. The same happens in the tap operator, where here we are using the default signal listener, which allows us to override just those methods that we will need for our purpose. In here, we are handling the next signal. For instance, the response entity on the screen comes from Spring web client that we can utilize to log the information about the next response. And the log is happening within the context of thread locals present, which means that in case of what we are going to see in the demo, the MDC contains the proper correlation identifiers. So before we jump to the demo, I just want to inform you what I used. I used the start.spring.io to generate a basic application with just a few dependencies. The Spring Web, Spring Reactive Web, to provide web client to my MVC application, and we will use the Spring Boot actuator at a later stage of the evolution of the application. So let's jump to the IDE. As you can see, the project contains a few modules. Each module that I'm going to explore is an evolution of the previous module to provide a set of changes that we are going to discuss. And in a few places, we will modify the code. But first, let's see how the project is configured. There's nothing special here. We are using Java 17. And the basic example contains the dependencies that we mentioned before. So let's see the source code. I will start with the application properties, where you can see that I am modifying the logging pattern level, which allows us to provide the trace information and span information from the tracing libraries, but we will not use those yet. They will be useful in the future. For now, we are going to add a CID key from the MDC of SLF4J, which is my shorthand for correlation identifier, and it should appear in the logs. The application is set up in the following manner. We start a regular Spring Boot application, which contains the correlation filter, which allows us to extract the name of the request parameters and put it in the MDC under the key that I added to the log pattern. The next thing we will have a look at is a simple controller, which has a mapping to the /hello endpoint, and it will just log that it has been called and returned. Let's see if we can get that to work. Okay, and the next thing I want to show you is my terminal. I'm going to call the local host with the hello endpoint and my name. I received the response, and let's review the logs. I can see that my name ended up in the logs. So by populating the ThreadLocal storage of MDC, I am able to use that implicitly in the controller. The next thing we'd like to review is a web client controller, which depicts the scenario where we are calling web client to get a file that is actually in my project, which is served by the Java 18's feature. Let me just type it. JWeb server, which just serves the files from the current folder. Oh, apologies. The demo is a bit broken. Is that Java 18, Java 17? Oh, apologies. I cannot start the server. Java 19. That's my mistake. I have Java 19 on the class. Okay. So if I call this web client endpoint, I should retrieve a response which reads the contents of the file and would try to log. Let's see if that works.
Just really quickly, Dariusz, as you're doing this, somebody is asking if you can wrap lines in the log console. So whether or not your IDE can do it right now, maybe maybe they're asking to see the right-hand side of it, perhaps.
Apologies. So let me try to do that as well. You mean this one here?
Yeah, I think if you can't wrap it right now, maybe folks just want to see the right-hand side at some point. So either scrolling or wrapping if possible.
Wish I knew where that was. I clicked something. Let me see the recommendations if anyone had something.
Oh, on the left side. Camel is asking the question about wrapping. Is saying that it's on the left side.
On the left side, right? Not here.
We'll figure it out. Camel, any other tips you have for us? Is it? Or I think if you can just move, does it allow you to show what's on the right-hand side of the screen, even if we don't wrap?
Do you mean this part of the screen, or do you mean the terminal?
So Camel is saying output logs window, and then left side. But if it's, I also don't want to.
Let me move this to bottom. Okay.
Output logs window. Yeah, I think that's enough, actually. If you can just scroll right or left and show folks.
Hold lines like this, I'm not sure if this would help. This one here. Apologies. Is that better?
Okay. All right. There we go. Done.
All right. Apologies for the slight delay in not knowing these features. Okay, where was I? So I essentially started the server. I wanted to call my endpoint for the web client. Let's try that. So this is the output, it's the file, and let's see what the logs contain. So it says web client endpoint called. I can see the correlation identifier. However, in the do-on-next operator, which comes back after the response is retrieved, I no longer see the correlation identifier. Something is missing. And as we can see in the log output, the thread has changed. So changing the threads causes our ThreadLocal storage to be lost. Is there anything that we can do about it? Well, the features that we added in Reactor recently allow us to capture the ThreadLocal context and store it in Reactor context. But for that to work, we have to use the handle operator, which can try to do the following. Let's try that, and let's try to change the log to contain the same log and see whether we can get the proper output. All right, let's try to rerun the application and try the same request. Oh, apologies, I'm missing the closing bracket. Let's try that again. Okay, here we need to provide the type. All right. See the request, and what we see here is the output. Still missing something. Let me see what I missed. I did a context capture. I used the handle method. And I'm missing something else. So I need to show you the file that is the application configuration, where we need to add some magic from the correlation, the context propagation library. And not to waste too much time on writing that, I'm going to open the next module, which contains that already here. It registers the ThreadLocal accessor, and this is the magic that the context propagation library does to transport the ThreadLocal values back and forth between registered accessors, and Reactor registers its accessor. So if we go to the web client controller and do a context write, like we just context capture that we just did, we should see the proper output. Let's try that. Okay, and if we go to the logs, the last log, which is the one coming from the handle operator, contains the correlation identifier. But what about this log? This one comes from the do-on-next operator. The do-on-next operator is the one that we didn't mention when we were discussing the interoperability of Reactor with the context propagation library, because it does not restore the ThreadLocal values. Just handle and tap do so in the default mode of operation. So is there anything we can do to improve this situation? Well, we added a feature that allows to make ThreadLocals available in all the operators. But bear in mind that restoring ThreadLocals everywhere in the chain is an operation that carries a performance implication on your application, because interacting with ThreadLocals is going to slow your application down. So every time you use ThreadLocals, you need to measure and consider whether you want to have them everywhere or whether you want to craft the logs with handle operator in specific places and not propagate everywhere. So let's jump back to the controller and let's rerun the application without changing anything here and see if calling the hook enable automatic context propagation allows us to see the correlation log everywhere. See the output. Okay, so we can log in Duo Next and we can log in all the others because now the ThreadLocals are propagated. Okay, so the next thing we'd like to try is to migrate our application to WebFlux and see whether it's going to close everything so it's cleaner. Let's see when we migrate the application to WebFlux. What changed? We removed the Spring Boot Starter Web dependency. And in our application, we can see everything was there before, as it was there before. And the filter is gone because right now we are dealing with a WebFlux application. So the filters from the MVC domain, the servlet domain, are no longer useful. But we will get back to the filters in a moment. But before we do that, I would like to discuss one way of using the context write and context capture operators in order to depict a behavior which we should be aware of. So the next thing that changed is we no longer return a string, we return a mono of string. So here we call the mono defer operator to provide a mono at the end that the calling framework code is going to subscribe to. And inside the defer body, we will put the MDC value. Later on, we will see if we can have a web filter do that for us. But for the time being, we are storing it inside our endpoint. We will call the loginfo method. And the next thing we do is have the same web client call, the same mapping, and the context capture. Let's see if this application is going to provide the same response once we make a call to it. And let's see. Yes, the web client controller logs with the correlation identifier. And also, once the response is back, it does that too. But there are some questions here. Do we actually need to put a ThreadLocal value to the MDC in case of a WebFlux application? Because there is no imperative code needed here. We don't need to store the ThreadLocals in place. What if we wrote them directly to the context? Would that help? Let's try to do that. If we use the context write and create a context which contains the mapping of our correlation identifier to the name, Let's see if that makes the application behave properly. Let's make a call and see the output. Okay, so as we can see, the first log is correct, the second is correct, but I mentioned we'd like to remove the MDC put, so let's do that and see what happens. So we no longer interact with storing to the MDC and writing a ThreadLocal value, but we write it directly to the reactor context and hope that the interoperability with the context propagation library allows us to see the logs with the correlation identifiers. Let's see what happens. And now, just the last log contains the correlation identifier, but the previous one is empty. So the one happening at the level of the defer method. And why is that? That is because, as you might recall from the picture of the operators and the rectangles, the green rectangle is actually what we can see here. The green rectangle applies to this reactive chain. However, this reactive chain on the outside has the defer subscribing to it. Therefore, at this scope, we are in the gray rectangle, meaning this context modification is not visible here. So what if we take this line away and put it at the end so that the outer mono contains the same context, and see if this helps. Let's make the call. All right, as you can see, the thread locals have been properly propagated to the MDC, and they're present in the entire pipeline. Well, the next thing that we can do is actually avoid calling this and try to work with filters. In our case, this is going to be a web filter. Let's import everything as needed. And here we extract the same query parameter from the exchange this time. And we use the context write to store it in the subscriber context for what the framework subscribes to, and down underneath it's going to subscribe to the mono that is returned from our endpoint. So if the parameter is present, we will populate the context with that value. So we remove all the code that we had related to that. Right now the parameter is not used. Let's rerun the application and see if this is working. Okay, so in both situations, we have the logs populated with the correlation identifier. Let me just see my notes if I'm on the right track. Okay, the next examples will be less work. In this case, we will revert to the MVC application and use the observation from Micrometer. So no more manipulation of MDC by ourselves. We will delegate that to the Micrometer. So we are restoring the web dependency, and we are removing the implicit import of context propagation library, and we are adding the tracing bridge for OTel in this case. Micrometer tracing interacts with OTel or Brave, and we can take advantage of those. So let's see what changed in the code. In this case, we will not be using context propagation the automatic way. And we no longer have the correlation identifier accessor. The logs should also be clean of that, so they're not going to be present here. But we will have the trace ID and span ID. And how does the application look like? Now we are returning the string again instead of a mono. We are back to imperative code. We log, and we return the response from web client by calling block at the end. And we again call context capture to have the present thread locals at the time of our endpoint being called to be stored in that reactive chain to make it possible for the handle operator or tap operator to restore the thread locals. Let's see if we run this application and make the call if we have some correlation logs. Okay. Let's see the output. So as you can see, the web client endpoint called contains two identifiers. The first one is the trace ID, the second one is the span ID, and they happen to appear in both places. Now, this is quite neat. What else can we do with the features of Micrometer? And the features of Micrometer that we are not even using in this case directly, they are present for our application to log with correlations, and also the observation that is attached to the reactive chain and is also present when our endpoint is called allows us to extract metrics out of that, and also the propagate traces if we if we use the proper reporters. But we will not focus on that in this presentation. For now, let's see what kind of reactor core features we can use to interact with the observation from Micrometer. In this case, we are going to use the Reactor Core Micrometer project, which provides a few utilities, which we will see in the controller code. First of all, we need to inject the observation registry that is going to be useful in the body of the endpoint. And again, we provide one log, we retrieve the response, and now instead of calling to entity, we would like to stream the lines from the file. And now what we are going to do is log each individual line, but attach an observation for us, for instance, to measure the time it takes to process a particular line. For instance, we could do something more complicated than just logging here. So we will use the tap operator to create child observations from the observations that are present. Apologies. So we remove the context capture. Is it needed? And we will see in a moment, once I run this application, whether it actually is. Okay, the output is the same. And as we can see, all the lines are printed, and all of them have different traces. And actually, what's surprising is that not only the spans are different, but also the trace ID is different. And this is where we will need the apologies. This is the point where we actually need the context capture operator. Because the observation is present when our endpoint is called, and we need to make the reactive pipeline aware of it by attaching it to the context. Then the tap operator with the micrometer observation listener is able to take advantage of it. Let's try to rerun it now. Okay, the spans are different for each line. However, the trace ID is the same. So this is what we wanted. And we will arrive at the last example, which is actually, again, migrating this to WebFlux. Again, the web dependency is gone. And the application is starting in the same way. We return a mono. And what changed here is actually nothing outside of returning the mono defer and not calling block. We still have the context capture. So the last thing to wonder about is this actually necessary to call context capture? Let's try to validate whether this works as the MVC example worked. Oh, I didn't stop the previous application. Let's try to rerun it. All right. So again, we have different span IDs for all the lines. The trace ID is the same. And if we remove the context capture, we are actually able to do it because when Spring Framework subscribes to our to the mono that we return from our endpoint, it attaches the observation directly using context write to our reactive chain. So the observation is already present. We don't need to capture thread locals with context capture. It's already there. Let's try to validate whether that holds true. And it seems it does. So actually, that's everything I had. I hope you enjoyed the demo. Apologies for my coughing.
No, that's excellent, Dariusz. Thank you so much. So first of all, I have to say this. I found personally this demo to be really excellent. I love the way that you broke down, showing initially each sort of the status quo, and then like adding progressively, and then showing how, you know, line by line, and relating that to the concept of the the operator scopes that you had shown earlier. So I think I really like it. Brilliant demo, I have to say. Thank you. And also amazing work, because it was, I don't do a lot of coding at all, and I've done very, very little reactive coding, but I do know that the logs were like, what is happening here? I have no idea. And so I imagine this is incredibly useful, and to see it applied also to traces and spans is amazing. So thank you for all of that.
Thanks as well. I'd be happy to answer any questions if there were any during my presentation, because I didn't monitor the comments.
Yeah, there's not a lot of questions, but definitely you have some positive comments. There's a couple of folks who are asking if the demo, if you can share the link to the repo on GitHub so that folks can replicate what you've done, what you've shown today. People feel free, I guess, if you have any questions before we wrap up here. But the only real question was earlier in the beginning, Renee Winkler was asking if you could maybe make some comments on the impact, I guess, or the relationship with Project Loom.
Oh, that's an interesting question. This actually has not much to do with Loom at this stage. Probably that's more a question about reactors relevance to Loom.
Yes. In fact, I'll post the question exactly. You're quite on target with the wording. Yeah.
I see. So exactly. Before I answer that, regarding the GitHub project, if you could help me, Cora, to share where can I post the link? How can I make that?
Yeah, right here on StreamYard. If you see on the private chat, if you can post the link there, and then I will copy and paste it and share it. We have people joining on LinkedIn. We have people joining on YouTube and on Twitch. So I can copy the link and make it available to everybody.
Let's start with that.
Awesome. Okay, here I go. All right, so I got the link, folks. Hold on. So here it is. I think that goes everywhere, but I'm going to show it on the screen because I don't know if I don't know if it goes to LinkedIn actually. So if anybody's joining on LinkedIn and wants the GitHub address, there it is for everyone to do this on your own. Yeah. So we and then we do have a new question, but I don't know if you want to. Do you want to go back to the?
Yeah, let's go back. Let's go back to the Loom one. Of course, I don't want to leave it unanswered. So. With regards to Loom, Loom has an amazing feature of virtual threads. I think everyone is excited about them. We are also looking at virtual threads. They haven't been made available yet. They're coming, as I believe, in October in the next release of Java. It is something that we are looking at how to integrate. The whole team of Spring is looking at the virtual threads and working with the MVC model mostly to take advantage. Loom answers. Loom as a general project in the OpenJDK movement is a more broad subject than virtual threads. So I can't speak to the incubator features. Because they are still in progress. But what's coming is virtual threads. So with regards to virtual threads, they tend to solve the scalability aspect, which is parallel to some of the features of Project Reactor and other reactive or non-blocking libraries. However, Project Reactor is not just non-blocking I/O. It's also the declarative way of coordinating various tasks, launching things in parallel, and being able to declaratively combine those. So I think those will keep on learning from each other and keep working together for the benefit. So from the perspective of Project Reactor, we are trying to be inclusive for all the paradigms and help everyone achieve their goals.
Awesome. Okay, some other questions we've gotten. Pavel says, does the new context propagation solution affect application performance? I know you did make a little bit of reference that if you do it sort of more broadly, it does, but yeah.
So the question is, does it affect application performance? And behind that question, we would need to first understand, does it mean with relevance to something else, or with relevance to a plain application that doesn't have, let's say, correlated logs? The context propagation and working with ThreadLocals in general is a performance, has a performance impact. But it depends on the application that you are creating, how much that's going to influence the runtime. So the only answer I can provide is measure how it works with the workloads that you have, and consider whether you want to enable the automatic propagation and see how much overhead that adds in your scenarios, or perhaps you want to do some manual work and use the handle or tap operators and disable the automatic propagation, and whether that proves to be more performant. And if that doesn't prove to be performant enough for you, you always have the option to interact with the context propagation library directly in the places that you actually need to have the ThreadLocals restored.
Cool. A couple of other questions. So Roman asks, so first, thank you for the presentation. Is it possible to use context propagation for Spring Security context?
This is outside of my area, to be honest. I believe the Spring Security project uses observation and by kind of the property of that interacting with the context propagation library, it is possible to have that, but I can't give a definite answer. I would need to reach out to the other folks. So please use Stack Overflow to understand and search the docs of Spring Security project.
Cool. And the last question we have here from Alexander Smirnov is, to make it work on existing application reactive code, should we add context capture operator?
So in terms of reactive code, assuming that the application is fully reactive, if that's the case, then most of the time you would probably be looking at context write and directly attaching the contextual information to the context and have an accessor. So please consult the documentation of the context propagation library to understand accessors and more of that kind of magic, to be able to restore the ThreadLocals out of that context for you where they need to be read. But for writing, use the context from Reactor. However, in case of mixed application where you have imperative code, where you have some ThreadLocals in place, you use them, and then you transition to a reactive chain, such as we saw mostly in the MVC examples in my presentation in the demo, then you probably need to use context capture at the places that you transition to the reactive chain before the block operator. And actually, one note that I might share, we are considering adding a configuration feature to allow the block operator to automatically capture. So context capture would not be needed in those scenarios.
Okay, excellent. I think that's all the questions that we have. So so thank you again, Dariusz. Thank you to everybody who joined. I know we have people, I'm sure people are all over. We know people are in Ukraine and Egypt from what they shared. So hello to everyone around the world. Thank you for joining us. And I just have a couple of things that I need to share before we close out, which are, let me make sure I do this correctly. Okay, so we have the Spring Academy website. Spring.academy has a lot of free material, free courses for learning Spring or for advancing your Spring skills. So please check that site out. And besides that, I mentioned at the beginning, of course, this golden path to Spring 1 is leading up to Spring 1 at VMware Explore, which is going to be in Las Vegas, August 21 through 24. So also please join us for that. And besides that, that's it for today. Thank you again, Dariusz, for the excellent presentation. And that's it. Thanks, everybody, for joining.
Thanks as well. Thanks for the engagement.
All right. Bye-bye.